Now that we know what scientific notation is, this lesson is going to be looking at ordering numbers that are written in scientific notation. Just something to remember from before. If the exponent on your scientific notation is positive, that means the number is large. If your exponent on your scientific notation is negative, that means your number is small. So let's take a look at this. This should seem like an obvious question. The question is, which number is larger, 1,000 or 10? We know that 1,000 is larger, but how many times larger? How many times larger we would be able then to divide. We'd be able to divide 1,000 by 10 to figure out how many times larger. Or you could just subtract the zeros. That would give me still the 1, but then I would have 2 zeros left because 3 zeros in 1,000 minus 1 zero in 10 gives me 2 zeros. So it's a 1 with 2 zeros, or it's 100 times larger. So let's take a look at this in the concept of scientific notation. So let's look at two numbers that are written in scientific notation. I have 2 and 1/10 times 10 to the 5th power and 2 and 1/10 times 10 to the 8th power. We want to know which one is larger. Well, we know that this one over here is the larger one. How do we know that? Because if we're looking at the exponent, remember, if it's positive, it's a big number. So they're both positive, but if we're looking at the exponents, that's the only number that's different. One's a 5, one's an 8. If I have to move the decimal over 8 times to make it bigger, it's going to be a bigger number than moving it only 5 times over to make it bigger. But I want to know how many times larger. I could go ahead and I could do the division. I could say 2 and 1/10 times 10 to the 8th power divided by 2 and 1/10 times 10 to the 5th power, right? I could do that. So I would have 2 and 1/10 divided by 2 and 1/10. I know that this part of it is always going to be a 1 because that part is the same number on top of each other. So I know it's a 1. But what gives me my exponents, if I'm just looking at this part of it in a division problem, 10 to the 8th power divided by 10 to the 5th power, I would keep my base the same, and then my exponents, we would subtract them. So 8 minus 5 would give me 10 to the 3rd power. So I would have 1 times 10 to the 3rd power, or basically a 1 with 3 zeros, because my exponent here is a 3. So I'd be looking at this being 1,000 times larger.